Would it be dx over dt?
Absolutely. X because it's distance in miles, hours. Okay, perfect. Awesome. Let's read on. Passes directly over a radar station. Okay, here's my radar station. So the plane is going this way and passes directly over a radar station. Fine. We read on. Find the rate at which the distance from the plane to the station. Stop. So here's my plane. Don't ask me to draw a plane, sorry. The distance between the radar station and the plane, the airplane. So let's denote this by something. Can anyone give us a letter? Please don't say D, please don't say X, and please don't say T. Choose anything else.
V.
V as in Victor?
Yeah.
Is that what you said? Or
V as Victoria.
V as Victoria, correct. Excellent. Good. So that's the distance. So let's go back. Find the rate at which the distance from the plane to the station is increasing when, that's the trap, after the word when the plane is 2 miles away from the station. Find the rate at which the distance from the plane to the station is increasing when the plane is 2 miles away from the station. So we have to identify what is the question in the problem. Anyone? Any suggestions? So I want what we're asked to find and also what this represents.
Can you repeat the question again, please?
Yes, of course. See how important it is to read the question several times? So a plane flying horizontally at an altitude of 1 mile and the speed of this passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when, when the plane is 2 miles away from the station. So what is the question? Give it a shot, please. Anyone?
One question, please. What does the P stand for?
Airplane, sorry. So this is planet Earth, and the airplane is flying 1 mile above the ground. It's passing over a radar station and continues. And we're asked to find the rate of change of the distance between the radar and the airplane changing when the airplane is 2 miles away. When the plane is 2 miles away from the station. Very important, 2 miles away from the station. So what are we asked to find? Anyone would like to give it a try?
Is it 1 squared times 2
We haven't
squared?
established what we're asked to determine. We cannot start equations till we know what we're asked to find and what this is. We don't know what equations to write if we don't know what the question is asking us. So what do you think we're asked to find? Do we want to read it again? Find the rate at which the distance from the plane is increasing when the plane is. Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. So what are we asked?
The distance between the plane and the radar, right?
But it says clearly.
So is it going to be dv?
Ah, because it says find the rate. The rate. Good. I'm ready. How do we write a rate? Yes?
The derivative of the distance in respect to time.
But which one?
dv dt?
dv over dt indeed. And what is this?
V?
Yes. Now we have everything established. Now we're going to form a right triangle. And now I'm ready for an equation. We establish what we're asked. Of course, when v equals 2 miles, this is a trap. We're not going to look at it. Good. So now which equation? Perfect. We establish what we are given. We establish what we're asked to do, to find, and now we are ready for the equation. Which equation did you have in mind? I think I heard Quinn saying it already.
The Pythagorean theorem.
Exactly. Very good. Knowing that this is 1 mile and knowing that this is x. So how do I write the Pythagorean theorem?
It would
V squared
V
plus
squared equals 1 squared plus x squared.
That's it. We have what we want. Now the next step is I differentiate. I put a dot so no one forgets what. Why do I put that dot in there? What is it for? To remind us what?
It's a function of time.
Excellent. Both of them are functions of time. I'm ready. Yes. Awesome. Well done.
To dv over dt.
2v dv over dt.
dv
Awesome.
over dt, yeah.
Good.
Down.
Perfect.
2x dx dt over dt.
Brilliant. Divide both sides by 2. See what I'm asked to find? I'm asked to find this. All I need to do is divide by v. So dv over dt equals x dx over dt, x times dx over dt, everything divided by v. That's all I needed. Now I have to plug in numbers. Now these are legitimate, or this is legitimate. Not up till now. They were trapped until now, but now they are legit. So dv over dt when v equals 2 and when x, can I determine x from here? Yeah. So if v is 2, then I have 4 minus 1. which is 3. So then I have 4 equals 1 plus x squared, or x squared equals 3. And of course, I can only use the square root of 3, not the plus or minus. Good. So I have everything. I have x, square root of 3. I have dx over dt. It's given to us 500. And I have v is given to us 2. Always make sure that all these numbers are in the same measurement unit. Yes, so I will do this and plug in. Careful. In this case, because the denominator is just one term, I can simply divide. It's 250 times the square root of 3. And I got 433.01. 433.01. We have to identify the measurement unit. What will the measurement unit be here? Can anyone tell us the measurement unit?
Miles an hour.
Yes,
Way.
miles per hour. Very good. Indeed. It's a distance, rate of change of distance with respect to time. Awesome. Well done. Moving on. Any questions? Okay, let's choose one of the motion here. Maybe the spotlight. You decide the next one. We can use or spend a month on this topic alone. Okay, any of these?
Can we do 18?
Good. Let's start with 18. 18. So let's dissect it. A spotlight on the ground shines on a wall 12 meters away. Say no more. Wall, spotlight. "12 meters away." From what I just read, this is it. Okay, let's continue. If a man 2 meters tall walks from the spotlight toward the building, leave it alone for a moment. Forgive me, I cannot draw a person. So the person moves from the spotlight towards the wall. It covers this distance. The person covers this distance, let's call it x. Let's read again. If a man 2 meters tall, okay, so I'm just going to say this. I put everything in there so I don't forget anything. Okay. So if a man 2 meters tall walks from the spotlight toward the building at a speed of 1.6 meters per second, stop. I don't know what this is, and if I can find out, I can't even read on. So what does this represent?
Is it dx over dt?
Brilliant, thank you very much. X for this, T for this. S for T. Good, awesome. How fast is the length of his shadow on the building? Stop. So let's take a look. When he is this far away, this is the height of his shadow, or the length of his shadow. But if the same person is now here, look what happens. This is the length of the shadow. So when he walks closer and closer to the wall, as you see, if this is, let's say, y1 and this is y2 in different moments, obviously initially was this, but now at this point is this. So the length y is decreasing. So I expect a negative symbol for the rate of change. So let's go back and read the last sentence again, or the whole thing again. So if a man, okay, totally has a speed of this, how fast is the length of his shadow on the building decreasing? Stop. What are we asked to determine?
dy dt?
Thank you very much. See, we're getting there. And now I'm going to read the trap. When? Okay, anything else that follows here is a trap. When he is 4 meters from the building. So I expect y to be a negative, dy over dt to be a negative value. And they're asking us to evaluate it when he is 4 meters from the building. And that's exactly what I'm going to write. At 4 meters from building. So this is a trap, don't even bother with it. It's not important. Okay. So he walks. His shadow on the building is decreasing as he gets closer and closer to the wall. We have 12 here. We have y here. We have 2 meters high. I'm going to draw this again exactly the way I wanted it to be. What am I getting at? What am I really showing?